hey, metal, it should be very hard, right? It wouldn't be easily cut open, but let's just try it here. So this is the blob of potassium here. And if you try to cut it, you see it's cut in half. It's actually very soft, and it just cuts like butter, so I put a picture of butter here. But never mind now. So let's just soak away some of the oil that's on potassium. It's stored under oil because it's so reactive, it reacts with the oxygen inside the air. So we have to store under oil under the absence of oxygen to make it non-reactive. Okay, and if I put some of it on water, okay, once more.
Okay, we'll try a bit more.
Try a bit more.
Okay, we're going to try and remove the oil as much as we can, and then we can let it swim on the filter paper and make it like a little boat. Okay, and then we'll cover it with this. Now you can dunk it in.
One more time.
Yeah. Slowly react. Nicer, isn't it?
Yes. So this is potassium, and it reacts with water so violently. The moment it touches the surface of water, it gives out a purple flame. And that actually is another demonstration of what happened in the flame test, and how when I burned the salts, which I put away unfortunately, it's just another matter of the change of energy levels in the electrons. And in this case, the metal, when exposed to water, it turns purple, and it gives off a hissing sound. And you could see some cloudy gas here. Do you know what that gas is? What is it?
Poisonous stuff. It's harmful. I wouldn't want to, inhale that. But may not be so toxic, but there's a lot of hydrogen gas in here. Okay, that's formed from the reaction. So we would not want to open this yet. I will bring this to the fume hood.
Okay, thank you.
And you can say goodbye to this one.
Okay, bye-bye.
Goodbye.
Bye.